Okay, we're back with the Elka. This is part 8. Set it up so I can test some things. And I noticed something interesting. Okay, so that's the drawbars. Now I'm gonna switch to presets. You can notice that the presets are a lot louder than the drawbars. But this is actually not a fault. Because it turns out, and this is why I removed the percussion VCA board, that if you enable the presets, the percussion, which normally has like a short decay, now becomes the flutes. So they actually repurpose the percussion circuitry for the presets. Which is kind of interesting. But the problem is, because the percussion is louder than the normal flute sound, which makes sense, and I kind of like it actually, that means that the presets are also louder since they use the percussion. So this is the LFO board for the string synth chorus. It has a lot of capacitors. It's 1, 2, 3, 4, 5, 6, 7, 9, 10, 12, 11. So yeah, but yeah, this is like a dual sine wave LFO that gets mixed together. This right one is a much lower frequency than this left one. I think about 8 times slower. So they get mixed together to make like this combined LFO shape that drives one chorus board, and then the inverted version drives the other chorus board. So it's actually a pretty complex chorus system between these 3 boards. So you can see all the capacitors that I've replaced so far. So yeah, anyways, this board is ready. It's been refurbished, so let's get that into the Elka, and then let's refurbish the chorus boards, and then I think I'm gonna test the string synth. Okay. I think that sounds pretty good. The chorus seems a bit fast, honestly. But I don't know how fast it needs to be, because I don't have any reference. Okay, I'm reading some articles on the Elka Rhapsody, which is the string synth that is in the organ. But I'm mostly concerned about the speed now. So this schematic actually says the frequencies for the 2 LFOs that get combined. Now I could grab my scope and actually probe my Elka Concorde. Okay, I got the oscilloscope hooked up, my little DSO, and here we indeed see, here's the fast one. So that sits at 6.1 Hertz, so that's good. Now you have the slow LFO, which is at 0.65 Hertz. One thing I do notice though is that the fast LFO has a way bigger amplitude than the slow one. And here we are looking at the slow one. There's only 4-volt to pick. That seems a bit odd. I think the strings sound good too, so... Right, I need to take a look at that one note that is funky in the highest octave. Other than that, it's all working. We got a drawbar organ, we got percussion for the organ, we got Leslie, we got string synth, strings and cello, we got piano and clavinet. Okay, this is the brass ladder filter, very fancy. I'm in the process of replacing the capacitors, and I have decided I'm going to replace all these little tropical fish caps too, because, well, yeah, that is why. Yeah, they fall apart. I hate these things, they are the worst. Some of them are still in good state, but there's quite a few, like these ones on this filter, that are just falling apart and need to be replaced. And all the other caps, like these greenies and the other ones, they are completely fine. Some ceramic caps here and there, they're completely fine. But these tropical fish ones, they just crumble. Well, I found another budge. And there it is in the schematic, C20, so nice squeezed in here, the corner. And on the PCB diagram, here it is too. Budged on there. Nice. Okay, there's the last few cables I need to connect. Specifically this white one, which is OBR, which is the brass volume. Because I want to test out the brass. So I need to find OBR on here and then get the brass working, and I think I have all the treble keyboard bits done then. And what I'm gonna do then, I think I'm gonna tidy up, because it's a bit of a mess. Okay, the brass has been connected. I don't think it's working. At least the sound is working, but... no envelope. So the brass doesn't go brown, and the delay of the Leslie it's also not working. Well, the envelope generator for the brass also does the delay for the Leslie. So that tells me that that component is broken. So I'm gonna have to pull the board out and take a look at it. Okay, so here we have the board and here we have the schematic. So there's several things I want to take a look at. I want to take a look at CC, which is the gate input for the envelope. So CC, pin 2, VB, although I can already guess that nothing is happening here. So looking at the PCB diagram, CC enters all the way on the right. So that's over here, because you're looking at the board like this. So gonna need to check that. Not much happening there, is there? Okay, so for comparison, this is CP. As you can see, that has a nice full swing of minus 25 volts. Okay, I am checking the transistor on the envelope generator and it does generate pulses. I'm gonna see on the schematic where that is, because those are 12 volts. Yeah, 12 volt pulses. So that does seem correct. Okay, I believe I connected my scope to pin 1. This is the collector. And here we have the collector. So, okay. Well, we definitely want to see 12 volt spikes there. So that's something. So the chip is a 74221, of which I did buy a few. So, okay. Let's check pin 2. Okay, message pin 2. I indeed get those pulses. Measured pin 4. Nothing. So I could replace this chip and see what happens. Well, I do have the 74221, but I don't have the 74C221, which is the version that runs up to a maximum of 15 volts. Since this runs off 12 volts, I'm going to need that version because the 74221 is rated for 5 volts. I need to find this version, which is on eBay, although it's a little bit pricey. I'm gonna see if I can get it somewhere. Well, I actually found a Dutch store which sells these, believe it or not. So yeah, that was rather cheap and rather quick. So let's replace this chip and see what happens. Okay, new chip. One thing I do notice is that the vibrato delay is working. So that's a good start, but no brass moi, no filter. So either something's wrong with the rest of the envelope generator somewhere, or something's wrong with the filter. Okay, this works now. This output VB works now. Now this needs to work. So I need to check pin 9 and pin 1, since those connect to these the rest of the circuitry. And I also need to check TA. Check if there's any enveloping going on there. Yeah, that sounds like a plan. And if that's all good, then I need to take a peek at this ladder filter. Right, so I measured all the outputs of the envelope generator, and that looks good now. It looks like something I would expect. Still no filtering though. Okay, so I measured this resistor, this leg right here. That resistor is where all the control voltages come together, from this trimmer, from the two envelope inputs, and then they go to these two transistors to the filter. So that's how the cutoff frequency is controlled. So I do see signals here, so it looks pretty normal. So I'm like, well, maybe the issue is one of these two transistors. Now, interesting. So what you do is you set your multimeter to diode measurement, and you measure from the base of the transistor to the emitter and to the collector. And then you should measure diode. In the case of a PNP, you should measure diode from the base to the emitter and from the base to the collector. Now I'm measuring this second transistor, which should be an NPN transistor, according to the schematics and according to the type that should be there. And I keep measuring a PNP transistor, because an NPN transistor has the same diode measurement but reversed. So from the collector to the base and from the emitter to the base. So I look on the actual code on the transistor and it looks like it is a PNP. So I think somebody had a go at this at some point and accidentally put a PNP transistor instead of an NPN transistor in there, because it does not check out. And here we have T24 and T23. Here's that resistor that I mentioned earlier. So I measured here, get a signal here. Goes to T24, which is an PNP, which is correct. Then it needs to go through this NPN, and well, this looks like an NPN symbol. I check the type on here. T23 NPN BC173. Okay, so here we have a BC415B, which is indeed a PNP transistor. So if I take my leads, connect the positive to the base, negative to the emitter, nothing. If I do the same for the base to the collector, nothing. Now if I switch it around, so the negative on the base, positive on the collector, I measure a diode. Doing the same for the base and the emitter, I measure a diode. So measuring from both the collector and the emitter towards the base, that means PNP. And this is also a good way to check if a transistor is still good. So even though this is a PNP transistor, this transistor is still good. It measures correctly. 2 diodes. So it isn't broken, it's just the wrong component. So let's find an NPN and let's shove it in there. Okay, I'm getting a much stronger signal on the resistor going towards the ladder filter now. To the ladder itself. So that looks very different now. So I think that's actually better. It still doesn't sound good though. But I did change these parameters. So I'm gonna see if I can tweak them and if it does any filtering. I do hear a little bit of a moi, so that gives me hope. Ah! We have filter action. That's definitely working now. I don't like the resonance of this filter, though. Okay, so it needs a little bit of further tweaking, but we have filter action now. That makes me very happy. So yeah, it was a wrong component on there. Well, okay. Now I do kind of want to do a little modification. I want to up the resonance a little bit because I replaced the capacitors in the filter with different value capacitors because I didn't have 47 nanofarads. I'll probably change the filter a little bit, but I do kind of like it. It sounds kind of meaty, so maybe I'll just keep it like this. So if I look on ladder filter schematics, then it's always this path from the output to this transistor that controls the resonance, or feedback if you will. So this resistor would actually be a resonance control, and you actually see this in the ladder filters in the solo section 2, is that there's different resistances that are switched in and out for different presets to change the resonance. So I think it would be kind of cool to lower this value just maybe about half. See if we get just a tad more resonance to emphasize that moi a little bit more. Okay, I bridged the 100K with a 33K. So let's hear what that sounds like. that's kind of cool. It's a little bit more wet, but yeah, I like it. So I was trying to figure out the noise attack, because that doesn't seem to be working, but it doesn't really make any sense either. So I decided to look at the Elka X705 service manual, and look, it's the 8-foot percussion. And it looks like this circuitry is exactly the same, except that some traces have not been cut, and you see here that this board is also exactly the same. In fact, these two connections are also on the Concorde, just not connected. So I'm thinking if I can't figure out the noise attack, I might as well just put the 8-foot in there. And this is just connecting this wire. I need to remove that. It's just connecting the traces on the circuit board, really. So that would be really simple, a wire and connecting two traces. So I'm thinking about it. The sustain doesn't work for 1 octave. These boards are responsible for the sustain envelopes. Now, since it's only 1 octave, I know it's just one board, so one of these boards might have a faulty connection to SFU, which is the flute sustain. So what I'm gonna do, I'm gonna grab my multimeter and measure the voltage on pin 1 of every board. I think it might be this one. Anyways, I'm gonna measure pin 1, which is SFU, because the sustain is just a voltage divider. So it should give a voltage on those pins, and then I know which one it is. Actually, I don't even need to measure it, because no sustain. Sustain. So yeah, that first pin of the connector is not good. I'm gonna have to fix that. Okay.
What?
I made the trace of the PCB a little bit thicker, so it actually pushes up against the pin more. And that did the trick. Yay! Okay, I think I can now confidently say that the treble keyboard stuff is all working. It's a mess, all these cables. They are individually loomed stuff, and that's all very nice, so there is order in this chaos, but it needs to be order and not chaos order. So before I'm gonna move on to the chords, first I'm gonna clean up and tidy up the treble stuff. And then it's all bundled together nicely, because there's still a couple of loose wires and loose ends, but those are for the other sections. I made some 3D printed cable holders, so I can add a few more and keep things a little bit more neatly in place. So let's hope that works out. So that is a lot of work done, but all the treble stuff is working now, or the polyphonic treble stuff anyways. So now I can finish up tidying the cable work. Tidied up most of the things, but some things are still a bit of a mess. And then I can move on to the chords. So I hope you enjoyed this episode, and well, I see you all next time. Bye bye!